an incredible person who I consider my friend, but he's my teacher, and is Tom Zimmer with us.
Oh,
hello,
great.
Tom.
Hello.
Hi, Tom.
Hi. Yeah, I recognize John Peters' voice and Peter Forth, of course. This is very interesting to me, but I don't know that I have much to contribute since I have been away from Forth for many years. Forth has a special place in my heart because I believe it was very important in teaching me how to think. And when you're a programmer, thinking is very important. So it's a pleasure to be here. I don't know if I can answer any questions. I'm currently living in Bartlett, Texas, a little tiny town northeast of Austin, and we have over an acre here, so there's plenty to mow. My wife does the mowing on a fancy mower that I bought her, and I'm still working full time. I will let's see.
Tom, you can buy a robot for mowing from FIC Taiwan. Professor Chiliu Sheng will provide you a robot after this meeting.
Oh, okay. I still work full time. I'm still a software engineer. I work in C#, and this is my my office. As you can see, the monitor has gotten much bigger over the years, and my eyesight has gotten worse. So that's very very important to me. Not much more than that to say, really. Just enjoying being here and seeing a lot of faces that I recognize. Thank you.
Fantastic. Thank you, Tom. Okay, now we go to, let me see, some guy here in South America, Argentina, my country. Where is Pablo? Pablo, are you ready?
Here. Hi. Yes. Well, here I prepare a video because my speak English is very poor. I start with FORTH, try to learning color FORTH, and make an experiment in C, and continue working with this this language. I show the presentation I make translated by my sister. I hope you understand.
Excellent. See? Go ahead. The audio is not good, Pablo.
He's not talking, it's coming from somewhere else.
From the microphone, no?
I wonder if he accidentally muted himself.
No, that's his speakers. And his speakers are too far away from his mic.
I try to turn off the mic.
You may have to keep that on because Zoom does not pick up what the loudspeakers are doing.
Well, this video is in YouTube too. I don't know if it can be better play with this.
on YouTube.
On YouTube.
Well, I will say something for the whole group, which I consider is very impressive. I met Pablo on the internet. We never talked before, only a couple of months ago, and he is the only guy I know in the FORTH community who created a social program with FORTH. He used FORTH to teach kids from the street, homeless kids or kids in trouble, to start programming. And then he took the color FORTH from Charles and created a game program and simplified it for the computers without Windows. Therefore, he used color FORTH, because color FORTH was a diskette. You inserted a diskette without operating system, and you had a FORTH running. And this man, Pablo, in Argentina, on the crisis of 2001, helped those kids on the street. So I am impressed for his mind and his energy.
Well, thank you, Peter. I like to see this video. In this video, I show how try to teach this R3 language.
Pablo, you can
yes.
put the video on the Facebook of
Okay,
FORTH2020, and all participants will see that. Everybody's interested in your work.
Okay, and well, I can tell you something else. My first approach to FORTH is color FORTH, and when I see it's very complicated, I try to learn reading the assembly source.
The assembly of color FORTH. Yes.
Yes.
Very easy. It's very easy. I do that when I'm biking. I read the sources of color FORTH. I do that.
Then I make a virtual machine in C. Try to understand this language. Then advance and put modification in the language for make more clearly. I see the majority of FORTH use or are for hardware development. I go to other direction is software development.
Software development. I understand. Look, Pablo, we will do the following. We both, you and me, we both need to practice English.
Yes.
Gart speaks excellent Spanish, Gart Wilson. Okay. And we will start those meetings practicing. For the next time, we will talk so good as Tom Zimmer. Okay. But now we go to Brazil, to my country. We go to
yes.
Lázaro. Is Lázaro there?
Yes, Peter. Hello, everybody. Can you start, Peter?
Yes, please.
Yes.
Thank you, Pablo. Thank you very much.
Thank you.
Thank you.
I will share my...
Lázaro, you are professor in São Paulo of Python. Your career is professor.
Sorry.
Can you hear me?
Yes. Okay. You can see the screen.
Yes.
I will talk a little about the PyForth. PyForth is an implementation of Forth in Python. I'm using the PyForth for Hinsin, and with the WinPython. WinPython is a Python implementation of Python with some packages pre-installed. It's more easy to learn. It's very easy to use. I use in my classes that they're in Python, and it's very simple to use the PyForth. You call PyForth and you can use the commands. I try to share the screen. I'm sorry. I try to continue. The PyForth has some simple commands, very simple. I just try to share. Oh, I'm sorry.
I think Dr. Ting promoted or showed Forth over Python.
No. To call, né? Então eu quero to try, né? The Python is very simple. A
Very
simple
excellent.
example. So, I'm sorry.
This is for teaching, no, Professor Lázaro?
Yes. It's for teaching. It's very simple. Has também a terminal for PyForth to try, né? And the future, né? I want.
Then this is important. Look.
Yes. I want to make a Forth course at INPE.
CubeSats.
Yes, and yes, to use the Forth onboard software for payloads and the small sats and CubeSats to teach the other guys to interact in Forth. Thanks a lot.
Thank you very much, Lázaro. Now I think it's my time. I will show you my screen. One moment. It's Peter. Can you see my screen? Everybody?
Yes. Yep.
Well, I received a brainwash thanks to these books. This was the man responsible for my brainwash. Here you see my computer, 1985, a 68K with a CPM 68K Forth. I built this computer above a single board computer.
Peter, we're not seeing we're seeing the same slide of all the books. We didn't see anything after that.
No? Oh, sorry. I go again. This is okay now?
Yes, but there you go. Now you're in presentation mode. Okay, now it's working.
Okay, I received a brainwash thanks this man here, Leo Brody, incredible. Of course, behind him was Charles Moore. Nobody can say everything else. This was my computer in 1985, Thinking Forth, the book, and a lot of little boards on the bottom. I produced that with the CNC. I started in CNC on that time. So I came back to Forth 3 years ago and started programming Win32 Forth thanks to the group of Tom, of Josh, of Howard, and other forces everybody knows. And we decided to expand this this 32-bit force to another one with the kernel of the Russian guys. It's an experiment. We are still in development. And this is the site of the group. We got a GitHub account, thanks Michel from Canada, with many examples. We try to teach force. The same programs run in other force too, because this is an NC force. And I collected from all around on the internet force bibliography and created a site. Everybody can download PDFs that are free. The purpose is only for teaching force, learning, and for newbies got their first impression of force programming. This is another view of some of the books we got. And I got also a YouTube channel. Sometimes I can create something interesting on force, and I do a short video so people can follow examples and interesting information also of Raspberry Pi. Here you see a Raspberry Pi, FORTH2020 install. I started this channel with Win32 Force, as you see below. I got a PDP-8 simulator made on Win32 Force and other information. Well, our FORTH2020 Facebook group is a friendly group. We try to bring people together from all around the world, make on Friday a gag. We have a Friday gag of force. And somebody told me, no, you will never learn force. No, the cat responds, I subscribe to Peter Forth YouTube channel. So he's more clever than many persons. Another slide here. This is some of the pictures of print screens from our FORTH2020. We have a GTK interface, so we got full access to widgets and full access to buttons and to graphical interface of all kind. We can insert pictures, everything. And you see on the blue side the force sources of this. It's all full with source. Another picture from FORTH2020 with graphics, words, and the editor. We got an included editor. We talk also in our group about internals of force. I try to explain newbies how well is force, how better is force in comparison to other language. Sometimes a guy starts a discussion and some friends help me. This becomes very exciting and interesting, and people try to show, no, this language is better than the other, and why you are programming on force, etc. And this is very interesting discussion of the language. Well, I started in the 80s with force. This is one of my products, force controller with the C-Log C8. This is from 85. This is a prototype board with the VME interface, bus interface. And 8080, 89, I went to the Super C8 chip. Dr. Ting does not know, but I wrote a lot of faxes to him from Argentina, and he was in Taiwan. He answered. He was developing the Super 8 ROM. And this was the next step from my CNC. We started with the CNC for drilling printed circuit boards. And I programmed the HMY, the human machine interface, on LMY Force from Ray Duncan. These are the
2
machines.
minutes.
Yes.
2
These are the
minutes.
machines I built and sell in Brazil and in the past in Argentina. They make molds. They work in the aerospace industry. But we started in electronics. This is a 5-axis CNC. Today we don't use any more force. In the past we used force. All you see in the past was force. This is in Peru, for example, a company who has 2 machines of us. One is 4-axis, the other is 5-axis for mold making. And I don't need money in real because I print my own money with the machines. We do coins. This is a customer in Brazil. He produces medals for sports. And this shows the precision of the machine and how much force can be used for interesting applications. Thank you very much. Does anybody have questions?
That's excellent. Machine control in fourth, man, that's the best.
Absolutely.
Don, we started very simple with force X, dots, X, step, and so. And it was wonderful. In the 80s, it was incredible language. It was a very ahead of other languages.
Why, I know you mentioned thinking fourth, and thinking fourth completely changed my brain on programming. And I code in C today, and I use thinking fourth.
Exactly.
You know, in C. So.
Yeah. Yes.
I always say that I code in fourth, even if I'm writing in C or Python or C++. It's a thought process thing. I totally agree.
It's a shortcut, no? We do more simple. Our programming is much simpler and faster, I think.
I agree.
Well, now it's guards. Are you ready for some?
Well, I guess so. Let's see if I can do my share thing. Well, not yet.
Do you need a little bit of
time? No, I think, well, I think I'm as ready as I'll be. So thank you, Peter, for putting this together. You can hear me, right?
Yes, perfect.
Yes.
Yep.
Yeah, thank you for putting this together. I have not been Zooming. I'm on my wife's computer because well, she teaches her second graders now in this bedroom that she has set up for it. My own computers don't have cameras on them, so I'm on her laptop in here with a hardwired connection. So anyway, but it tells me what I need to do to, you know, prepare better for our next meeting. Anyway, my interest has been in really control of things on the workbench, taking data, automating processes, and so on. And the interest really started getting intense in the mid 1980s, where I was working. Excuse me. And at the time, a friend had an HP 41 calculator, HP 41 CV, and he could connect a lot of things to it. But I didn't feel like I could justify the price for it yet. But then soon after, I was I was the only engineer in a small company, and we had to set up some testing, and I got a excuse me, got a 41CX with the HPIL module and extended IO, which goes to the interface converters to IEEE 488, RS-232, parallel, and so on, and you can connect all this stuff all at once. And so people would nearly wet their pants when they saw a handheld device controlling a rack of equipment. And it was much easier to program than the PCs of the day, especially, and of course laptops hardly existed. Well, pretty soon my calculator was getting used all the time for production testing. I hardly ever got to use it, so I let them use that, and I got an HP 71. I'm going to go here to, let's see, share screen, that one, and now why is it, oh, let's see, multitask, that's not the one I want. It's, well, now I can't get to the tab that I want to go on. Well, let's go back to this. Well, now I can't get the other screen back. Well, I'll just keep talking here. So the HP 71 is where I learned Forth. I bought the Forth module for it. Not a very good Forth, but being Forth, of course, you can expand it. You can add things that you don't, that it's lacking, and so on. And then pretty soon I wanted to have much finer, microsecond control of things on the workbench, which I couldn't get with either of these. HPIL is a maximum of about 8,000 bytes a second. That's much too slow. And so I got into the, it didn't take, well, the Hewlett-Packard catalogs came every year. You remember it was like, I don't know, 1.5 inches thick, and all this wonderful equipment, which I could not afford. But it didn't take a genius to figure out that you can, you could make your own computer with A to D converters, D to A, lots of various I/O. And so I set out on that. I really wish I could find how to get to that tab. Oh, let me try this. Uh-oh, minimize. No, that's not what I want. Exit full screen. Oh, okay, here we are. Okay. So brought a little bit of show and tell. I'm not in my office, but on my I tell about my main workbench computer, and I don't know if you can see this on the camera. Let me get back here. Ah, there we are. Homemade thing, but I have.
This is wire wrap, no?
Yes,
Garth?
yes, wire wrap. So I have about 80 bits of I/O on this. UARTs, analog to digital, digital analog converters. I can do real-time audio sampling and things like this on a 6502 processor. Do fast Fourier transforms and various things. And that's the way it's controlled is shown here on my web page. There it tells what it has. If I go down, can you see all of this? Are you able to see that, the page there? How it is controlled? If you go down there, if you go down.
Now we have your face. We're still looking at your face. The screen is not sharing.
Oh, okay. All right. Now does it show?
That's better. Yep.
Okay.
All good.
So So if you go to that page, and I put the URLs for these on the Facebook group. So it has, I have Forth in its EEPROM, including an assembler. I wrote the assembler in its original form. It only took me a couple of hours. And then later, a great thing I figured out just by accident, since this is Forth, macro capability is automatic. And wow, that was really nice. But so the host computer, because this one does not have, you know, full keyboard and monitor and all of this, host computer sends instructions as plain text. So you use a text editor, write your program, and just mark a block, send it over the serial line to the workbench computer, which will interpret or compile or assemble on the fly as appropriate. And it can do that while it's doing other things at the same time. And so in Forth, I can, you know, write a new piece of code and try it immediately. So it's been you know, a lot of fun to use that to, like when I'm figuring out how to use a new, let's say an SPI IC, or various, try various experiments on the workbench for things that I'm considering putting into a design for one of our products. So I don't actually use the Forth in the products. I use it to develop them, and then I use or microcontrollers generally to control the analog products. The analog features, procedures. What do you want? What's the word I want? Processes. And several years back, I thought, why not use Forth type structures in assembly language through macros? And so hopefully, are you able to see this, this screen here with some source code?
Yes.
Yes, so this is actually assembly language, but you'll see here a case statement from Forth. Case of, in the case of it being 0, do such and such. Here's the end of. If, end if. It's structured slightly differently because of the microprocessor.
It's fantastic. First, for that is incredible. When I started also with I was programming in macro assembler, I did the same you are doing there.
Yes. And I show on a couple of my web pages how to form these Forth-like structures in assembly language. So there are various ones of them, and they can be nested as well.
Incredibly powerful. Incredible.
I formed it took a while to figure out how to do the stack necessary in the assembler, which ran on the PC, how to form the stack for the nesting of the you know, the various program structures. But I go into that in some detail in the various web pages.
Excellent.
1 minute, 1 minute left.
Okay. I don't know. Let's see here. I have also Forth for 65816 microprocessor, which I plan to publish, very full featured, with log and trig functions and time alarms, multitasking and various things. And most of the work that remains to be done is just to document it well. Any questions?
Not questions. Yes, yeah, please, go ahead.
I'm sorry, you're using a semicolon before your comments?
Oh, yes, because it's assembly language.
So that works, okay.
And so the, yes, this is, the point here was to illustrate the use of Forth-like program control, flow control structures done in assembly language with the macros.
This is impressive, excellent.
Good documentation. Amazing. Time's up.
Thank you.
Okay. Thank you, Garth. Now, Abraham, are you ready?
Yep, I'm all ready to get started.
Where are you, Abraham, from?
Can you hear me?
Yes.
You can hear me well. Okay. Yeah, if everyone can hear me, I'll go ahead and get started. Yeah, if something breaks up, just ping me in the chat box. Okay, Peter, thanks for inviting me as always with this really esteemed group. I'm a graduate student in microbiology and bioinformatics here in Atlanta, Georgia. I really don't use Forth much at all for work. I use really Bash, Perl, piping, grep, set, and awk together for solving different bioinformatic problems. But for fun, I use Forth a great deal. I really like it's fast, it's small, it's both interpreted and compiled, and you can extend it from a low level to really high level vocabularies. So what I'm going to talk about is the system PygMeForth that Frank Sargent developed. It's a 16-bit Forth system that was developed for MS-DOS, but there's also versions for ARM Cortex MCUs and a newer version that's 32-bit and 64-bit based on Python, like Lazaro's PyForth. But that said, I haven't used either of those. I'll just talk about DOS PygMeForth. It's direct threaded. There's a built-in editor, assembler, metacompiler, and multitasker. I think you can have 15 files open at once. All this in less than 20K in MS-DOS, used back in the 90s. And I think the last version was released for DOS was released in 2007. You can compile your own small DOS programs within the small memory model, 64K programs by metacompiling the kernel plus any words of interest, and then you set whatever execution word to start the program to the word boot or pointer boot. But anyway, so something that's awesome about PygMeForth, and John and Peter and I were discussing this yesterday, is that it has an inline 8086 assembler, and you enter in your opcodes and instructions in the proper way, in good postfix notation. You add in assembly code using the code word, and in a second I'll pull up DOSBox and show you some words of vocabulary for basic DOS CGA graphics. So I'll go ahead and pull that up, and then hopefully I can share my screen and you'll all be able to see it. Let me know if there's any trouble. Okay, share screen, and I'll pick the correct window, hopefully. Okay. Does everyone see DOSBox filling the window?
Yep. White text, black background.
Awesome, perfect. As expected. Okay. So I'm in the last version of PygMeForth. I'll go there. Yeah, that's the contents of the directory. And I'll first take a look at the words I've written for CGA graphics in Vim, mywords.fs. Okay. So the first, well, forget that. But the first word here, vidinit, initializes video graphics using the interrupt hex 10. It sets it to mode 6, which is 640 by 200, 2 colors. I then implement words, more code words you can see here that'll either write a byte to a particular address in video RAM, which starts at B800 hex, and then it's interleaved with even rows all adjacent to each other in memory, and then followed by odd rows. So that makes things a little complicated. Another word to read from video RAM, and I can put all this in GitHub for anyone who wants to look at this further. Some words for rotating bytes and words, converting a X coordinate to X addresses, and so on. I'll just keep going through here. Okay, I think that's probably good. Anyway, you can take a look at that on your own time. And now let me load up Pygmy and then get to the punchline. I can include source with include my words Oh, come on. Yes. Okay, we'll start our graphics. Okay, and get some nice line art. There you go. So hopefully everyone saw that line art pattern. It's a bit slow. You know, I might adjust the line drawing algorithm, but you know, I could extend this a lot. Anyway, I'm going to quickly conclude here. I don't have too much more. I also like taking old computers and using them for new things. I want to integrate those with Internet of Things, and the other four systems I use are DragonForth with Paul Moss. I'm starting to use MidForth, which works on flip phones. It's based on J2ME, and PuniForth, like Peter has used quite a great deal on ESP8266. So I guess my future interest, and maybe I'll present at a future meeting, is linking with Internet of Things applications, helping with ham radio, APRS communication, home automation, getting data off weird formats, and then lab automation tasks, knowing in real time when experiments succeed or fail. I also have a video on my YouTube channel. I plan to make a PygMeForth demo and DragonForth and other systems there. And let me know if you have any questions. And thanks again, Peter, for inviting me.
You are awesome, Abraham. Impressive. Your YouTube channel is outstanding. I recommend to everybody have a look.
Yeah, I can put a link in the chat. Okay, and I'll stop sharing. There we go.
Okay, Abraham, thank you very much. Another friend from Köln, from Germany, wants to say hi to the group. And after that, Bill Ragsdale from SVFIC. One moment, Bill. Where is Thomas? Are you there?
Yes, I'm here. Can you see me?
Yes.
I have to put on the power supply. Do you hear me also?
Yes.
Okay. So I'm calling from Köln. Thank you, Peter, for inviting me. I worked with Forth, as we talked about earlier, with LMI Forth. This was in the mid-80s, from 85 to 87. I made my my physics diploma at the University of Bonn, and we used this Forth for real-time data acquisition system. It was a very good time at that for that time. This Forth compiler interpreter, and we used PCs and also some single board computers. And yeah, now I switched to Python. I was also on a Python board here in Germany, and we are encouraging young people, girls and boys, to get into programming and to get to learn how to think. And we think programming is a very good thing for this, and maybe I will use also Forth. So thank you. And
excellent. Thank you very much, Thomas.
Thank you. You're welcome. Bye-bye.
Okay. Bye-bye. Thank you very much. Now is Bill. Bill, are you there?
Yes, I am. Coming through fine?
Excellent.
Loud and clear.
Good morning, good evening, good night, Forthers around the world. Thank you for this opportunity. I'm Bill Ragsdale, a voice from the misty past of 40 years ago. I was a mere child when I set out on this fourth adventure. As an introduction, I'll cover some personal history and some Forth history. It may sound like bragging. Well, it is. In 1979, I wrote FigForth and published the FigForth Implementation Guide. As far as I know, this was the first Forth not written by Charles Moore or Forth Incorporated. FigForth was liberally inspired by Dean Sanderson's 1600 Microforth from Forth Incorporated. Along the way, I founded the Forth Interest Group and began publishing Forth Dimensions. Our Fig members were enthusiastic, but no one had a running system in those days. So I ran the implementation workshop, bringing public domain Forth to about 10 processor families. During this time, the Forth Interest Group grew to 30 chapters around the world, over 3,000 members, and a paid manager. Finally, I was the chairman of the Forth 79 standards team for about 2 years and was on the Forth 83 team. Oh, and by the way, I added the words only and also to the language. Before we get started, please click on your speaker if you have it. The slides today are very detailed, and so now onward to D charts. Just a second, I will get there. We are live. So my presentation today is exploring the fourth wonders of D-charting. Flowcharts are the classical method for documenting program flow. Today, we're going to learn a better method, D-charts, which was created by Edgar Dijkstra, who also coined the phrase structured programming and did a lot more. He received the Turing Award in 1972. So here's what we'll cover today. First, we'll explore D-chart symbols. Then we'll see their structures. Then we'll go on to the combination of D-charting and forth structures and see some actual programming examples. Here we see Fourth Dimensions from October 1978. FIG founder Kim Harris memorialized D-charts in this issue of Fourth Dimensions, Volume 1, Number 3. Incidentally, it was typed by my wife 41 years ago. So thank you, Kim Harris and Edgar Dijkstra. On the left, we see the classic historic flowchart symbols that are still used today. We find 6 symbols which were connected by lines. There is no structure imposed. It's the Wild Woolly West. You draw them as you like them. On the right, we see the 5 D-chart symbols. The vertical line means a sequence of actions. Below that is a branch or fork, which marks the conditional branch, the if then else. A circle means an n-way branch, a case statement, and a circle with an X is a switch. It's a branching origin, and it's usually the return point for a loop, an exit point for a loop. Finally, a solid circle marks the repeat point of a loop structure. That is, the loop is implied to return to its corresponding switch point. Now that's it. No boxes, no templates, quick to draw and redraw. So here are the D-chart principles. The application of these symbols is quite straightforward. First, programs start at the top and end at the bottom. Sequential statements appear vertically. Lines show the control paths. And finally, all lines go downward or to the side. So here's some quick examples. We're going to follow many more later on. The if conditional branch begins as a test. That's the branch or the fork at the top. True proceeds one way, usually to the right. The false part is optional in the other direction. And if the false part is missing, flow goes directly downward. Here's an example of a loop. It has several variations. The switch, which is the circle with an X, marks the start and the return point of a looping structure. The solid circle denotes the loop end and the return point back to the switch point. Upon concluding a loop at the switch point, execution continues downward. Again, action flow is always top to bottom. A variety of tests and branches may be done, as we'll see as we go along. Here's a case statement. It begins with an n-way test at an open circle. The diagonal lines lead to possible execution paths. All paths return to a common flow at the bottom. Now let's look at the pros and cons. First, we'll look at the pros in favor of D-charts. D-charts have more information per page. They're quick to draw for rapid revision. You have no need for a template. And they're context-free for any language. We can use D-charts wherever we're doing programming. And in fact, it's good for a thought press. We can help, D-charts will help us whenever we want to think through a problem. The cons, well, and finally, they're context-free for any language. Next, the cons. D-charts will confuse those unfamiliar and require extended explanation. You all are now going to be familiar with D-charts, but if you used them to explain to others, you'd have to explain the D-charts to begin with. And secondly, they're not particularly suitable for publication because, again, the unfamiliarity that people would have with them. So a little more detail. Here's a two-way logical test. This is our if-then-else. We see the test at the beginning, the if operator, then we see the true action, else the false action, and concluding with then. Here's an indefinite loop. The indefinite loop in fourth is simply a begin, do stuff, and then repeat it again. There's no exit. D-charts has an entry point and a repeat point. There's no need for any code below the switch point because execution will never reach it. This would be the outermost loop of an operating system. In fourth, it's the classical quit or outer interpreter. The only exit would be from a gross error or a reboot. Think of it, the indefinite loop. This calls to mind the song, on a clear disk, you can seek forever. And now the definite loop. For us, it has the form of a limit, the do operator, looping actions, ending in the word loop, which returns to do for a possible conclusion. D-chart simply has a switch point specified by the looping parameters and then a dark circle at the repeat point at the bottom right. This structure would typically be used to print a fixed length text string. The indefinite loop. Here's another form of the indefinite loop, which is begin until. In this case, the exit point is at the bottom. Begin marks the loop start. Looping continues until a conditional test at the concluding until is true. Execution resumes just below the initial begin. Another form. In fourth, another indefinite loop is begin while repeat. Begin marks the switch point. Stack parameters control while, which either repeats the looping action or else returns to linear execution at the bottom. So execution flow would go from begin to repeat up until the point when while becomes false, and then execution exits and returns, continues. Here's a couple of examples. We're going to explore in the fourth context the high-level definition of the word abs, the absolute value, fourth word. Dupe 0 less than checks the input value. If it's less than 0, the number is replaced by its 2's complement. Otherwise, the original value remains. We see the code on the left is only 3 lines long, and of course the structure on the right is very simple. Here's one that's much more complicated. This is a number conversion. It's a code fragment to convert a stack number into text. The digits would come out as hundreds, tens, units, decimal point, tenths, hundreds, and thousands. It's structured with 2 loops, 2 do loops, which do the math conversion, and then the printing of a decimal point in between with the 46 C comma. The D chart at the right clearly documents the process. We see the 2 loops, the little short 46 C comma in the center for the decimal point. Now here's one that's very complicated. It's a flow chart at the left where 2's complement arithmetic. Even though I couldn't decipher the full operation of that conversion, it was easy to duplicate the control structure as a D chart. So we see on the right, there are 2 loops, and within inside each loop, there's a number of conditional changes. So now we have an overview of a program I wrote a few weeks ago. This prepares a printed report from a selectable number of rows and data fields from an imported CSV file. It has 2 do loops to process the rows and columns. The if, else, then handles text and number formatting. I'll read through it briefly because the fourth code, this is written in pseudocode, which it and like fourth can read very nicely if properly structured. First, we read the file and set parameters. We begin for and seeing if another row exists. While rows remain, we look for another field. While fields remain, we check to see is it a number. If it's a number, we process it in a number format. Otherwise, we process text format. Then repeat for the next field, repeat for the next row, and we're done. Here's the equivalent D chart. D chart is a quick way to understand and explore the entire structure. We input the CSV file, we set it up, then over all the rows, there's a switch point. Over all the fields, there's a switch point. Then we process the number either as a text or a number, repeat for the next field, repeat for the next row. There it all is in a nutshell. So in summary, D-charts are the world's simplest programming language. D-charts augment writing pseudocode, and you capture the whole program or just a part of it on a single piece of paper. I spend 80% of my time working on sheets of paper, developing structure, functions, and codes. Then I edit light. Here's the D chart of a prime number search with code fragments. Again, as I write this, I improve it, I hone it, figure the logic, especially check the conditional flow control, write a few code fragments on the side, and then I'm ready to go live to actually do the forth programming. So this wraps up D-charts, which were resurrected from fourth dimensions in 1979. Any earlier code would have to have been written on stone tablets. Thanks for the opportunity to discuss one of my favorite topics. Do we have any questions or comments?
Thank you very much, Bill.
Yeah, I actually have a question.
Go ahead.
Hey, Bill.
Yes.
If you could go back to the slide that has the D chart of the report generator, I have a question about how that flow works. Try not to take long here.
Number one, I've closed the application.
Oh, okay.
Number two,
right.
let's not get lost in the internals of code. The main the main message for this, the main message for this entire presentation is remember that flow goes downward. A fork point is an if else, and the X circle and the dot is a loop. And after that, you can take it from there.
Okay. Thank you very much, Bill.
Thank you. Thank you very much.
Incidentally, a small commercial. Win32 Forth was begun at my company. Andrew McEwen, who started work for me back in the 70s and 80s. He started Win32 Forth as a little private project with my okay, passed it to Tom Zimmer, and the rest is history.
And it still lives, which I will show you. Anyway, Bill, my little understanding, are you able to take, for instance, some forth code and change it to a CSV file and come out with a flowchart, or no, it's just a tool that you use on the side?
I received that question a couple weeks ago, and it began to inspire me about automatic translation from forth code to D charts. And that's a mental project that's been going on. I've been structuring how to put that together, but it really works the other way around. The D chart comes first and then comes the code. And I don't think it's practical to go that direction automatically. I think you could go automatically from code to a D chart.
Okay.
Again, thank you very much. Great presentation, great people.
Thank you, Bill, very much. Then, guys, now I think we got everybody as scheduled. Everybody was in the listing did his presentation. Somebody else wants to talk a little bit?
I could explain something. Oh, you want to go first?
Go ahead, Howard.
Okay, just very, very quickly. I've been trying to fix some hardware while this has been on. I've got to try and get some hardware working for Monday morning. So it's a long story, and the hardware that I'm supposed to have requires a relay board. So they didn't have one for me, so I've made one. I can hold it up here. It's plugged in. Hang on, I'll unplug it a little bit. Okay, it's a Texas Instruments MSP 430 launch pad with relays. That's all it is. Oh. And it connects to the test hardware, which is a rat's nest of wires now. Anyway, I'd wired something incorrectly, So in order to try and debug what was going on, I wanted to add an LED. And I've been scratching my head as to why the LED didn't light up when it's supposed to. And the reason is there's some 8.2 kilo ohm resistors in my 1 kilo ohm box downstairs, and I didn't check them. Anyway, so a long story. So I think I've just found it, so I'm just going to fix it after the meeting. But I just wanted to say that I'm actually using Forth. I'm using ForthInc's SwiftX for the MSP 430, and it's extremely sweet and easy programming environment. And it helps me to write what is actually quite a complex control program for the relay board, hopefully by Monday morning. Anyway, I want to say as well, thanks very much for organizing this. Okay.
Thank you, Howard, for participating.
My pleasure.
Peter, I think
Howard, I want to say, Howard, another thing. Howard is another guy from the Win32 Force community who was very helpful to me. Every time I needed his help, he was there. Thank you very much, Howard.
My pleasure. I mean, it's such fun, all this Forth stuff. It's like in the world of programming today where I work, I'm programming in Python. I'm going to use PySerial to interface to this little board on Monday. I think the ideal for most of the people that I work with in a commercial way, they would not like to see Forth, and Forth will not die. It's one of those strange things. Okay, some of us are dying. We're certainly getting older. But the Forth itself is such a neat idea that it will not die. And every so often some young person comes up. There's a guy called Josh Stone, I think his name is, and he did this evil VM based on ColorForth loosely, and it's really cool. So he's raving about how powerful it is, but of course we all know that. So anyway, I'm very happy to help with ColorForth, with Win32 Forth, with any other Forth. It's all such fun.
Thank you very much, Howard. John, okay. Before you start with your with your exhibition, I got a friend.
I'm going to have to leave sooner, but go ahead.
Yes, 1 minute. He wants to say hi. Bernhard. Hello, Bernhard.
Hello. Good evening.
Hello.
I'm from Austria. Welcome.
Hello.
Hello.
Hello. Hello.
You drive an observatory, Bernhard. An observatory.
Yes, a little observatory in Austria. I have
wonderful.
CAF, and yes, oh, beautiful place.
Yeah,
okay,
I know.
Thank you.
Bernard has incredible picture from the outer space with his scope. Is outstanding, and I love you are in our group, Bernard. I love very much.
Okay.
Okay.
Yes, thank you.
Thank you, John.
Yeah.
Go ahead.
So assuming you can hear me and you can see my blue screen?
No.
You cannot see the blue screen?
No.
Okay, here we go. Now you can.
Yay.
All right. Just a little background. I'm looking on an iPad. That's the audio. I'm working on a desktop, so I'm actually signed in twice. That's the only way I know how to do it. This is Webley, which is Win32 Forth. And before you say that there's too many words, yes, there are. But anything you want to find is probably in there. Now, I want Tom to know that I'm and Bill to know I'm very proud of extending Forth onto the web. As you may know, any web browser can come over here and you'll see this. And it even has a file manager. So you can see the files that people have saved. I've typed in starting Forth up here, get file. Hopefully it will work. Don't see it working. Typical problem here. How come? Oh boy. Let's see. I gotta make sure Win32 Forth is alive. I let people come online and do whatever they want. And sometimes things happen. So I use VNC to go to a Surface computer at my friend's house. And it says waiting to accept client. I'm gonna just start it over. several clicks there, get rid of this. And there's a batch file to bring it up. Now let's go back and see if get file will work. Well, maybe in a month. Of course, all the plain stuff works. Oh, this is a file. Let's see if I can copy and paste that down here. Oh, I've got a little typo there. Pretty basic. I don't know what's happening to my file loading. And so I might, one thing I keep telling myself, if I go into the contract generator, you guys are going to get lost really fast. But I think I have to do that. So since this isn't working.
John, you made an incredible work with this Win32 Forth Online. It's impressive.
Well, it's compliments to Tom Zimmer and the other people that started. So here it shows that it's a whole database. And if you see line 18, it says that a circuit breaker is $300 per 100. So that means it costs $3, and it's 20 hours per C. So it's just a few minutes. Just a minute, Kathy. I'm online with 40 people. So if I type the CV over here, it tells me, and if I put total.
You got some periods headline between the 2 and the 4 and the 4 and the plus, which is why Forth errored.
I'm sorry, wife was talking. Say that again.
Between the 2 and the 4, there's a period, and the 4 and the plus. That's why Forth errored out.
Yeah, there was. I corrected that, but
okay.
There's a bigger problem with Webley not working. So
the fourth code of John is for commercial purpose. He drives an electricity company, no, John?
Yeah, I used to do a lot of estimates. Now you can see.
And when I see your sources, I only see signs of dollar. You make a lot of money, John. Of course.
Very funny. I want to show you the primary extension that we've done is in WinEd, and it's an editor that I'll challenge anybody to have a better one. So I have the ability here, if I go, first of all, the decompiler, of course, works, but I made this shorter version of C, which is, if I SE, it just shows you the stack comment. So if you look at dupe, excuse me, short version, it just gives you the stack comment. So when you're poking around in Win32 Forth, it's so big that typically people think they're going to type words. No, I'm sorry. First of all, it comes up in electric words. So if you want Forth words, that's fine, but this actually takes a minute to get all the way through here. And on Webley, it's way too short, too much time. CLF gives me CL. Let's see, clear screen. My brain is failing me now. I want to show you how I create a bid. Create a bid. So this brings up something from a template. And this 5-line, when I go in, normally I copy all this text up here into that place. And this thing is sensitive. It's like if everything moves down, then all these answers won't work over here. Now you're still with me. Somebody say, okay.
Yes, John, I'm here.
Okay. So somebody wants a kitchen plug. So if I hit F2, it tells me that's $354. And they say, that's lovely, but let's put it on a dedicated circuit here. So we'll just put in a CV in a circuit and do F2 again. Now, at this point, I like this thing up here. It says an experienced electrician will do it in 2.5 hours. But if you're just learning like a handyman, it'll take 3 hours. It'll take, the labor would be $450 and the parts is $40. So we have all kind of different things. Here's Karen. She wanted an emergency light and a paddle fan. And later on, she decided, okay, well, the emergency lights are for one group and the paddle fan is for me. So I split it into just the fixtures. Let's see, why did that not open? Well, I guess it did. And there's the other thing. So, oh, somebody's drawing on my screen. That's fantastic. Wonder how you guys can do that. Maybe I'm doing it. No, I don't think so. Let me check my list of what I'm supposed to be talking about here and see if I have my timer working. 2 minutes left. It's a funny thing. There's this word stuck in this system. By the way, VB will take me to the source, but I'm in gold. This means that I can't trash anything. No matter what I do, hit the delete key, it just won't. I can hit the insert key. Just a minute. Insert key. Green is insert mode and blue is overstrike mode. But let's escape back to the console and view test. Now here's, maybe you guys understand, but from Tom Zimmer, Dudley is a little afraid to, what is, oh yeah, test. He's a little afraid to remove this, but it trips me sometimes. It's common to make a test. Yes, sir?
No problem. I think we saw everything about this contract generator. Are you going to present in this Friday on SVFIC meeting?
Sure, I'll present all the times. Maybe Webley will work.
Okay.
Before we go, I guess you guys have seen the URL on various places for Webley. Just use a browser and go there. If it crashes, just send me some kind of indication. It doesn't hurt. We have some black hat people around. One guy crashed it and caused the screen to be all green. That was a good one. But anyway, I encourage you to try it. Now, there's no use using words to get familiar. You need to try actually putting some code.
We are without time, John, because
okay, so just put in some code, and that's it for me. Thank you very much.
Thank you, John.
John, put the URL in the chat.
Okay, and let me tell you one more thing. I'm leaving to go take a lesson on how to ride an electric unicycle.
Don, are you going to follow after John to continue?
I'm leaving my abode to go outside. Is that what you mean? Oh, turn off Zoom or turn off share screen. Oh, I guess you did it. Okay.
Don,
good.
are you the next one? Don?
Sure, I'm ready.
Okay, go ahead.
Let's see. So I'm Don Golding. I'm at Jacksonville, Florida. I work for a company called Made in Space. I'm a senior electrical engineer here, working on the first robotic spacecraft, which I'm going to show you. This is called Archinaut 1. You can put Archinaut 1 in YouTube. This is a 3D manufacturing system. It's going to be the first time in history that a solar panel is actually 3D printed. The backbone of the solar panel here, it unfurls a solar film, and it's going to go out to be 30 meters. So it's going to be a very large solar panel. Made in Space, Jacksonville, and actually they're looking for people, if anyone's online that wants to move to Jacksonville, Florida, and work on really cool stuff. The company's has a machine that makes fiber optic cable in zero gravity, which is the purest fiber optic cable you can get. We've done that already, and they're gonna be going into production here in the next year or two. They also can make crystals in space. They're going to make large structures in space using our 3D printer. I'm working on the flight computer that's going to be running the whole system, including the ARM and the 3D printer. I'm working on that. It's FPGA based because it's a radiation environment. We're using a RISC-V inside because we have all C programmers. I actually have 2 people at Made in Space, software guys, interested in FORTH, so I'm nudging them along. One of the things I said to them in the software group meeting, I said, imagine this. We have 100 machines mining out at Pluto, and we need to do a software update, okay? Are you going to send a C binary module for each 100 machines on a low-speed data link when all you have to do is send the source code, and everyone knows what a deferred word is, so you could update, you know, words very simply using deferred words and a very low-speed data link, right? And then I also interactively showed them create does. How you can extend the compiler. You can't do that in anything else. You know, I program in C. It's yeah. Anyway, I don't need to go any further with that. So anyway, so that's what I'm working on at work. My FORTH stuff is I had a company from 1990 through 2000, and my goal was to build intelligent machines. I used a new micros. This is called, let me introduce you to Whiskers. Whiskers is a robot, and it has a 868 8C11 from New Micros. And I sold about 2,000 of these into the education market. So for at least 10 or 15 years, in tech ed in junior high schools, kids were learning to program in 10 hours time on this FORTH-based robot. And I created a very high level language, which I call English. It's actually, I call it TOS, Triune OS. And they learned constants and variables and loops, and Whiskers was an intelligent robot. You could tell it to go forward, and if it hit something, it would go around it without any programming. And I could, you know, I have many different things I could discuss during our meetings. So I'm just trying to give you an overview. I actually built the first man-packable robot for the US military, which was this guy right here. This is called Intruder. By the way, you have to go back on my Wayback Machine.
Don, I want only to say one word for other people who don't know so much FORTH. FORTH was created by Charles Moore in an observatory, in an astronomical observatory. So FORTH is related to space from the beginning. It was an astronomy controlling program, or a program for control astronomy instruments. So for robotics from first day.
Yeah, exactly. Machine control and FORTH are like this, you know, and where I work is all machine control. So gee, yeah. So this was actually the first man-packable robot built for the U.S. military that I designed. It used the same board in my Whiskers. I built it for U.S. Special Forces in 1997. It was before iRobot's PackBot, okay? So I was there before iRobot, actually. So I designed quite a few different machines. This was kind of an interesting one. This robot here, I designed it for a science museum in Atlanta, Georgia. And you can see it would follow a white line. So you put a white and black line on the floor and you change it any way you want, and it will follow it. There's optical sensors, so if somebody walks in front of it, it would stop by itself. There's this is a wide belt, motorized belt, so it'd go up to you know, the wheeled rack, you know, where the boxes come down. It would sense that with a light sensor, and then it would pull the box on there and go drop it somewhere else. So I designed a lot of robots. This was my advanced whiskers that actually used a network of 2 controllers. And so this guy, and I'll do a talk on my Triune OS. I think you'll find that fascinating. This actually used whiskers at the base with 1 CPU and a second CPU for a long-range sonar that could see out 20 feet, and the head could move around, so the head could map out the room while the base is doing collision avoidance. How much time do I have?
We close with you, Don. I don't know how much time, but we will close when you finish.
Okay. The very last thing I just want to plant a seed with, Ilya, I absolutely love what you're doing. You're way ahead of me. I was thinking along similar terms. So I came up with this idea of a 4th supercomputer that uses an FPGA with a 1 or more 4th cores in it. What I wanted to do was use a meg by 36-bit SRAM for the video buffer and an FPGA code written in Verilog, for example, to run the LCD. And then I'd have 1 meg by 36 non-volatile SRAM for the main system memory, an SD card, and then of course keyboard, mouse, serial port, USB, and then just to get, you know, Wi-Fi and stuff, just use an ESP32 connected in there. So I actually designed this for another company I work for. Basically, they wanted a SPA controller with a super cheap GUI, just like Windows or Apple, the Apple interface, but they wanted it super cheap. So I designed this GUI controller with like a 320 by 240 LCD screen, and it cost like $15, I think. And when they finished with it, it looked identical to like a phone with icons and touchscreen and the whole 9 yards, and it was super cheap. So what I basically did was, there would be Verilog code that is running the LCD and scanning the addresses, right, of the LCD through the SRAM. This is, I don't show it, but this is actually dual ported SRAM. So you can write and read from the same memory location at the same time. So think in terms of putting, you know, like an icon or something, building in an SRAM, or even a whole new, maybe even a whole new screen. And you could load the screen in a 60th of a second, because all you're doing is copying the address right into the LCD, you know, into this memory. So these are some thoughts that I have, and I just want to kind of introduce myself and what I'm doing.
Excellent, Don. Impressive.
Yeah, that's really cool. Did you say you're in Jacksonville, Florida?
Yes.
Because I was just trying to link in with you, and it says something about California. Have I got the right Don Golding there?
I just haven't updated. I came from Silicon Valley. I was working for Made in Space in Silicon Valley. Yeah. Yeah, I need to update my LinkedIn. But yeah,
that's okay. Just as long as it's you, I'll click on link then.
Yeah.
Cool.
That's me.
I got to go. I'm being nagged by my wife. Food is on the table. So
we are all going, Howard. Thank you,
Peter. Thank you.
Thank you very
Peter.
much.
Hey, this has been so much fun today. It's fantastic.
Look, it's for the first time we got South America on the map of force. So Dr. Ting should put a mark for South America, Australia, Taiwan, Russia with Ilya, and hope next time we got more friends. I think we got 2 friends from Russia. So it's wonderful. All Europe as usual, no? David Kani came to the group also today from Czech Republic. Many friends from China, Taiwan. Regrettably, I don't have any contacts in Japan, only 1 or 2 guys, but the hour was very difficult to get everybody together, no? but it was a wonderful meeting. It's excellent to see you all, guys. I appreciate so much.
Hey,
Thanks.
Dr. Ting, yes?
Yeah, I just want to show you this lattice ECP3 kit. Okay, somebody in SVFig gave me this board, and I recently thought, well, I might want to do some fourth again, and I remember this board, so I went to, online and check out the tools. But the lattice, the free diamond design tool doesn't include this one, okay? And I look up this the software tools. It will cost me $1,600 to get the tool, which would program this ESP3 FPGA. Too expensive.
Dr. Ting,
Yes.
check out Libero, because Microsemi bought Lattice. No, did you say it was Lattice?
Yes, Lattice.
Oh, okay. I'm sorry. Different tool.
It's Lattice. Okay. So
Then,
well,
I propose the we will meet again next Friday. Is Friday done? The meeting for you?
No, it's always the fourth Saturday.
Saturday, okay.
Fourth Saturday.
Next week. Next Saturday.
Week. Okay. We will put the link very, very big in our group, in the FORTH2020 group. This is the house of Dr. Ting. So I want him, please somebody take him very firmly, because I'm trying, I can't. I am too far away, Dr. Ting. Please bring him to my group. I love Dr. Ting and I love FIG Taiwan.
Thank you.
So you must come to my house. It's our house and it's the house of SVFIG. We learned everything from you. So.
Well, it's I think we are, in spite of the COVID, we are houseborn.
Yes.
But we just cannot travel.
Okay.
It's too much for us now.
Then, please, Dr. Ting, use